Welcome to Physics Made Easy channel. And today, first I will revise the previous topic, that is coding schemes for digital system, and then we shall be focusing a bit on Unicode, and then onwards transmission media or the communication channel. This shall be the focus of our today's lecture. Now, coding scheme for digital system. Now you know that the digital system works in bits and bytes. Now the very simple coding scheme for digital system, it has been BCD. BCD is binary coded decimal system, and it has got only two digits. We know that it has got only two digits, and one of them is 0 and the other digit is 1. So it means we can just code about 3 to 4 numbers. For example, 00, 10, 01 and 11. Four numbers can be coded like this. Now, another standard for information is ASCII. ASCII is American Standard Code for Information and Interchange. This is working very successfully till date. This is universally popular, but now it is being replaced by Unicode. Initially, computer systems, they were restricted to first America and then to the European countries. So they only covered the European languages. In fact, not European languages, only English. English was well understood in Europe. So it contains the word from English and then some of the Greek letters and alphabets. So it was just a 8-bit system. In 8-bit system, you can create 256 code combinations. And there was another important theorem that is known as Fourier theorem. Fourier theorem says that any rectangular wave can be shown to be made up of a large number of sinusoidal waves. You can just have an idea from this diagram. And sinusoidal waves will be made up of harmonics. Harmonics, they will be having a fundamental frequency, and then integral multiple of that fundamental frequency forms the harmonics. In this way, a rectangular wave can be broken up into a large number of sinusoidal waves. And the next, we will focus on the systems and the specifications. Facts, now it is outdated. It reproduces the original document, which is a static one. Mobile phone. Mobile phone is for communication, and we are well familiar with it. We are using it these days. Email. Email is a message sent by a computer network. And then teleconferencing. It is a system in which a person sitting at a colored television screen can see and talk to each other. Now, this is very much famous, and some of the famous apps in this area. They are, Zoom, and then we have got Skype also. So during this lockdown time, this is the most important way of communication. And the next is communication. Satellite, radio and televisions, they communicate via this media. And after that we have got GPS. GPS is a navigation system from where we can see the locations and positions. And it's also a new technology these days. And another important part is Unicode. As I have already said, ASCII caters well to you can just say English and some of the Greek languages, and it contains, you can say, basic numbers, decimal system, and then English language, and then Greek. Now the computer has in fact spread to whole of world. So we have got a very large number of languages. So then this 8-bit system, 8-bit ASCII code was outdated. So what earlier was done, there was a concept of fonts. You have the font of every language, and that font was used to work on a computer using ASCII or 256 or 8-bit codes. Now, with the passage of time, we have to give representation to all the languages of the world. A new system was devised, and that is called Unicode. In Unicode system, languages from all over the world, they have been assigned codes, and even codes are reserved. For example, a language is having 35 alphabets, and then that language has been given 40 letters with anticipation if 5 more are included in it. So Unicode is now a computer standard. For example, Ravi font. Ravi font in Punjabi is a Unicode font. And when you are writing in Unicode, then you don't need fonts. Then you don't need fonts. So Unicode standards, they have led to the removal of font culture. You can directly write, and now these days they are very much popular in your smartphones. And now let us go to today's topic, which is transmission medium and communication channels. Transmission medium or communication channel is a link through which the information masses signal may be propagated. Communication channel is the link through which the information of the masses is being propagated. This is very important line. It is used to propagate the masses from source to destination. Now, transmission media is divided into two parts, or it is of two types. One is guided transmission media and second is unguided. Guided transmission media, it is used in line communication, or guided media is used in point-to-point communication, as you can say telephone. In telephone, first connection is established, and here we need the guided media. Now, the guided media has been further divided into various examples. You can say parallel lines, twisted pairs, and then after that coaxial cable, and then optical fiber. They are the guided media. Optical fiber is most popular these days among them. Optical fibers, they are used to deal with the guided signal in medical sciences as well as in telecommunication. Now, unguided media, we have got unguided media as well. In unguided media, it is used when there is no point-to-point contact between the transmitter and the receiver, and in this case, masses can be made to receive to a large number of receiver. In point-to-point communication, it is one-to-one communication. Masses is conveyed by one person, received by the other. But in unguided transmission media, source of the message is one and the receivers can be in lakhs, as you see in your television. Free space, one media of communication is free space. It is used in space communication and satellite communication, such as in radio and television. The characteristics are quality of transmission medium, and they depend upon. Now, quality of transmission is very important here. Quality of transmission, they depend upon the nature of the transmission medium, and then they also depend on the nature of the signal, because if it is a sound signal or a voice signal, then quality may differ from the video signal. Video signal has more penetration power. Video system has more delays. We will just see it in the coming lectures. And next part is bandwidth of a transmission media. Bandwidth is very important. More the bandwidth, more the signal space, more signals can be transmitted. First is coaxial cable. Coaxial cable, it is a widely used wire medium. Now it is almost outdated, and it is a bandwidth of 750 megahertz. These cables are generally operated at 8 gigahertz. Now remember this, it means some kind of modulation takes place. Concept of modulation will just be discussed after some time, and before that I will have to give the concept of free space. Free space is communication through free space using radio waves. Free space uses radio waves at frequencies ranging from 105 hertz to 109 hertz. And then optical fiber. Optical fiber has a frequency range of 1 terahertz to you can say 1000 terahertz, microwave to ultraviolet. And optical fiber can offer transmission bandwidth in excess of this. Optical fibers, they have revolutionized your bandwidth and your internet speed. Now the calculation of channels. Optical fiber cable guides light from one place to another. The frequency of optical fiber, it ranges from 4.5 into 10 raised to power 14 gigahertz to 7.5 into 10 raised to power 14. If we were to allocate a, for example, FM radio channel 200 hertz, then it means, for example, we have got a range of you can see 7.5 into 10 raised to power 14 minus 4.5 into 10 raised to power, you can just say 14. If we calculate the difference, it comes out to be 3 into 10 raised to power 14. 3 into 10 raised to power 14, then it is divided by 200 kilohertz is the wavelength. 200 into 10 raised to power 3. So we can create 1.5 into 10 raised to power 9 channels. Remember this way of calculation, it's a very simple way. And question has been asked on this way of the calculation bandwidth. You can just say you have to, if you have to calculate the number of channels, you should know the bandwidth of the channel and just divide the range of the frequency. Just divide it by the, you can just say the frequency at which you want to make the transmission possible, and actual number of channels will be slightly less than 1.5 into 10 raised to power 9, because we have to actually leave some gaps between the channels so as to avoid the noise. All these topics, for example, coaxial cable, and then particularly this free space and optical fiber communication. Optical fiber communication has been discussed in optics. You can see the diagrams from there, and free space communication. This will be discussed in the very next chapter with a very good diagram. So till then, kindly wait for that lecture. And now I will just outline name of the services and frequency band. Now the question about this has been asked in MCQs or the objective type. Standard amplitude modulation broadcast. This is 550 to 1600, you can say, kilohertz. So it has got a very low frequency range. Then FM broadcast 88 to 108 megahertz. Whenever you listen, you can say FM radio in your cars, then kindly note down the frequency. It lies between 88 to 108 megahertz. Check in your cars. Television 54 to 72 megahertz, and then 76 to 88 megahertz. Very high frequency TVs, and then ultra highs 174 to 216 megahertz and 420 to 890 megahertz. And then cellular mobile frequency, and the range of this frequency, cellular mobile radio, it is 896 to 901 megahertz, and this is mobile to base station. Now, to communication, one signal goes from your mobile to the base station. The frequency range is different. Note the frequency range 896 to 901 megahertz. This is mobile to base station, and then station to mobile is different range 840 to 935. So these two ranges, they are different. It is usually done to you can say avoid any kind of interference. Next is satellite communication. Satellite communication, the frequency range, there are two kinds of frequency range. Note it down. In satellite communication, there are two kinds of frequency range. One is uplink and the other is downlink. So this is the uplink frequency and this is the downlink frequency. Uplink frequency is 5.9 to 5 to 6.4 to 5 gigahertz, and then downlink frequency is 3.7 to 4.2. Now these two frequencies are mutually exclusive. In satellite communication, there is a clear indication. Mutual exclusiveness has been ensured so that no interference takes place. Now I will once more cover it down. Standard amplitude modulation. You just note down the range of this standard amplitude modulation, and this range is 540 to 1600, 540 kilohertz to, you can say, 1.6 megahertz. So this is the range. And FM broadcast has got the range of 88 to 108 megahertz, and then television 54 to 72 megahertz, and then 76 to 88 megahertz. This is very high frequency for the TV, and ultra high is 174 to 216 megahertz and 420 to 890 megahertz. Cellular mobile 896 to 901 megahertz, 840 to 935 megahertz. Mobile to base station and base to mobile station, these two are the different frequencies. Usually it is done to avoid the interference, and in case of satellite communication, there is clear indication that they are doing it to avoid the interference of the signals. Actually, this is something unwanted, because one interference comes from the atmosphere, other from the superposition of the waves which are moving in the media, particularly wave going to the base station and wave coming from the base station. With these words, I finished this lecture. And in my very next lecture, I will start with antennas. Thank you very much.